So today I'll be explaining what's a thread by simple definition. Okay, so I'm going to create a new file in my VS Code. It's a Maven project and nothing much is going on here. So I am going to create a class in intro to threads.java. Okay, that's my class name. So I should have the main method, public static void method. So this is going to be like the entry point. So if I run, I have like, let me try to close everything. Right now, I don't think I have anything other than the run execution that I see in here. Okay, so it's not showing anything. So what I'm gonna do is I'm gonna show you guys how we can utilize a thread, what sort of thing that we can do by using threads. Okay, so if the first thing that I would do, I would ask you guys to uh, write. All right, you can give me ideas. I will be doing the coding. So what we need to do is we need to create an application that's uh, gonna be uh, creating. The main purpose of the Java code is gonna be making uh, a, a code or piece of code that calculate the summation of first 100 numbers. Okay, so we can do such a thing by do I have continue? Yes, I think this is my AI assistant. So I'll be using AI, at least not that much of AI, but some sort of help to speed up the typing and all those processes. I'm not going to type everything by myself. I will say write code to get the summation of first 100 numbers in Java. Okay, so let's see what it gives. Hopefully a good one. It's not always, gonna be the expected one. Sometimes it's gonna give nonsense, but hopefully this one have given the exact thing that I wanted. So it's very simple. I'll just copy the public static void main. Yeah. So what it does, it's basically taking an integer and name it as sum in here and showing as starting initial value of 0. Then what it does is it's gonna loop through this section from 0 to 100, and the summation would be adding in ith position. First scenario it will be 1, second scenario will be 2, and the summation will go up to its maximum. So if I run this application, and the summation of the first 100 positive integers is 5050. I hope this value is correct. Okay, it should be. The machine is doing the calculation for me. Okay, so based on this calculation, based on this observation, what you guys can see is I'm looping through this 100 numbers and adding those numbers to this variable. Okay, so I can make changes in here, maybe 1,000, 10,000, or 1 million, based on the number of iterations that I go. It will calculate the numbers. You can see it's really powerful when it is coming to calculating. I think I can go maximum integer max value. That means the maximum value of an integer is taken here. The value is this amount. So this is the maximum value that an integer can hold. So I will calculate that. And you guys can see even it is taking a little bit time. You guys can see that it's not giving me the answer correctly. Why? It's calculating a huge number. Okay, it's calculating a huge number. Now it is taking a lot more time than calculating 100 numbers. Okay, still I haven't got the response in. Okay, so it is one by one, it is calculating the number. Okay, so you guys can see this process. I'm not sure whether you guys can see my CPU stat, but it's going crazy up. Okay, it's right around like 50% of my CPU is utilized just for this. Okay, so you guys can see this kind of this kind of calculations that what we are doing right now is not something what we called divide and conquer manner. Okay, so this is a basic example of serial computation. Okay, we calculate the summation one after another, one after another. And we do not have any divide and conquer. We have no parallelism involved in this section. We have no divide and conquer mechanism. That means all the things that is executing in here happens in a serial map. Okay, so what I'm gonna do is I'm not gonna think it will be executed uh, clearly or executed within this time frame. It might take a little bit, but you guys can see the number that we are having, the huge number that we put in, the maximum value of, I don't know how to pronounce this in number, but you guys can see it's a lot of numbers out there. Okay, so even if I take this number and max value and I will divide it by 10, that means the half of this value. Okay, and if I try to even run this, yeah, I think max value is this amount. Let me check, put it in here and save it, run. So it's taking a lot of time to calculate, right? This is not gonna be calculating anytime soon. Okay, so what can I do about this? Okay, what is the uh, alternative way? This you guys can clearly see it is not calculating fast enough. It is taking way more time to do the calculation. So what sort of things that you guys can think to speed up this process? How we gonna speed up this process? Yes, tell me what are your thoughts? What sort of things that you can think to make this calculation much more faster than this? Yes, anyone have any bright ideas? Even I would make this one little bit easier for you guys. Have numbers around here. So it's around 1,000, 100,000 and 1 million. I don't know. I don't have a clue about this number. So the positive integer showing a negative number, right? I'm not sure why. Positive number integer is that this is probably something what we call the a huge number that couldn't be shown. But let me cut it down a little bit. It's 10,000, 100,000. I'll have a little bit more. It's even getting 550. Run. I want to like make it stuck for a while. Let's see what is that magic number. It's not stucking. It's not even that. Not even that. Nope. Nope. Yeah. So it's taking little bit of time. Okay. Max value. Probably the max value is something that we can't calculate on one go. Okay, so I need your ideas, guys. So this max value cannot be calculated at once. So what we can do to make this process very easy or make it process much more faster? Yes, tell me. What are the things that you guys think that's gonna make this faster? Yes, any suggestions? What are your suggestions to speed up this calculation? Calculations gonna be easy if you do this and this kind of thing. Yes, guys. What sort of ideas do you guys have in order to speed up this? So this is like a thinking pattern, okay? I'm not just trying to show demonstrate. I need you guys to think what we can do. Okay. Integer range is -1. Max value, I think to yeah, might be the range is coming in minus is the reason, but I am counting from 1, so the integer max value is up to this number, so it should not come in minus values. I'm not sure why it is. Yeah, any suggestions that we can do to make this speed up? Yes, 100, 100,000. It's coming a minus number. Let's try to like print it out. System out sum will be a huge log, but yeah, it's printing out. Printing out takes a lot more time than calculating. At some point, it is going negative. I think that's the equivalent of like showing it in what do you call that? E numbers. Can't really know its name, but E numbers should be the scenario in here. But anyhow, our objective is to speed up this process. How we gonna speed up this process? Printing out is like to show you guys what's numbers that I'm getting. But in order to show this number, I have a double value. Yeah, it's E numbers, so it's huge number, that's why. So how we gonna speed up this process? Any suggestions? Floating points have like really huge numbers. Integers have less accuracy. Yes. In this scenario, what we can do is we can actually divide and conquer. That means what I will take a small example in this scenario. So I have 100 in here. So what I can do is, rather than calculating all these values, rather than calculating the summation of first 100 values, what I can do is, yes. So one of you guys got the answer. Divide the max number into equal few parts. That subset of numbers can calculate it in one block, then iterate, then execute few other places. That means rather than if you want to calculate sum of, let's say from summation of we need the summation of 100 to 500. Okay, so first iteration we will go from first 100 to uh, first 100, then we go to 100 to 200. Okay, so we have the summation of 100 to 200. Then what we have 200 to 300. Likewise, what we're going to do is we go until 400 to 500. That means the total of summation of one from 1 to 500, we will chunk it down. Okay, first 100, second 100, third 100, and fourth 100. So in that scenario, we get a chunk of our data. Then what we can do, we can calculate this these values, and what we can do is we can divide and conquer. Okay, we can divide the value as we like. Then what we will be doing is get the summation of all these things in one single go. Okay, so let me get a sample of that. Get version of first 500 numbers, but in 100 blocks. Let's see, we can get summation of um, yeah. So in order to do this, what we need to do is we need to chunk up these values. Okay, we need to chunk up these values, and we need to calculate those things in an orderly way that these are executed one after another. So I'm going to do something really dumb in here. Okay, but I need to prove a point. That's why I'm making this assumption. So I'm going to create another public static. It's going to be an int. Let's call it cal get sum or something like that. Get sum. And what I'm gonna do is I am gonna return the sum variable. Okay, so I'm printing out. So I'm gonna get integer start, and so it's the other way around. Start int int start int end. Okay, so the summation that I'm gonna get is from the start to end. Okay, So what I'm gonna do is I'm gonna pass in these values one by one. Okay. So how I'm gonna do that? So first I am gonna call this method and get all those values rather than looping through. I will say int. I will say uh, sum 100. That means I can get sum from 1 to 100. Okay. So what I'm doing right now, I am dividing my work, to get the thing done. Sum, let's say 200. So the starting point would be 101 and think 200. Okay, let's assume my math is good. Okay, let's do it for like 500. Otherwise, we are wasting a lot of time. So this is starting from 201, and this is starting from 301, and this is 401, 3000, 300, 400, 500. And the summation of all these things gonna be, don't need this, int sum is equal to sum 100, sum 200, sum 300, sum 400 plus sum 500. Semicolon, don't forget. Now what I'm doing is I am calling this get sum method and getting the summation of that and get the sum of next iteration and so on and so forth. Okay, we can loop through even this one to get a better understanding, but I just want to show you guys how if we think rationally, how would we do that? Okay, so if I run this, I think the value is correct. It's showing a good number on here. So likewise, what we can do is we can start off this and get the summation on each and move along. So the summation happens rather than we calculating one by one, we are getting the summation of chunk by chunk. Okay, so we first get the sum of from 1 to 100, then 101 to 200. Likewise, what we do is we will go through these values and get the summation from to 500. I hope this is correct. Let me verify first of all. We Google what is the sum of first 500 natural numbers. Actually, it is correct. It gives 12125 250 125 250. Yeah. So my calculations is correct. So this is the summation of that. So what I'm gonna do next, is this make clear, guys, what I have done? So rather than calculating one by one, what I did was I created uh, I created some of I created the summation from 1 to 500 into smaller chunks. Then I took the summation on each and get the final sum as the output. What I have done is clear for you guys. Raise your hand if you got the idea what I'm trying to achieve in here. Okay, cool. So next thing that I'm gonna do is I am gonna make I can do few things. Can make this even for huge numbers. Okay, rather than calculating this kind of algorithm. Let's make it more interesting. Let's make this in a loop and I will try to make it uh, uh, into smaller chunks as well. Okay, so what I'm gonna do is what for, give me a for loop for I starting from one argument length, let's say 500. Okay, so in here we are incrementing one by one. Okay, so I'm gonna increment it by 100. So we have the same effect as what we have in here. Sum is equal to plus and equal get sum, starting point is I, and the endpoint is I plus 100. Okay, so 5 iterations. So I should get the exact equal amount of numbers, 1 to equal 5, but otherwise it will not work. Let me check. Did I have the same output? Nope. What did I do wrong? First iteration is 100. Okay, I should start from 0. Give me a second. I'm doing something wrong. Get sum. That means I am getting the 0 to 100. Should be 1 to 100, right? I plus 1, I suppose. Okay. Then for the next iteration, when I equal 101, 101, then this becomes 101 plus this is second. My maths is not good. Start with I. Second I becomes this is I think no get system out. What's the value of I, and let's see the values of I first. 1 and 551. What? Okay. I think it should be 500. Till 500. 101, 200, 200, and 401. The I1 I values is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that is correct. And I plus 100, I think that one I got wrong. I plus 100, should be something wrong there. I is integer. I think I need to put colon in. Okay, 205. Okay, I think it's going up to 501. Should be 100, 200, and okay, I think it should be -1 here. Because okay, there you go. So what I'm doing is rather than calculating the sum like this, I have put it in a for loop, and it gives me still the same result. Okay, the same result of 500 by I'm getting the first 500 summation, but in terms of chunk of 100. Okay, let me make it uh, more readable and more configurable. I will say chunk. Okay, chunk is equal to 100, and I can say this is the chunk size, and this is the int final int. Let's say int is 500. Okay, so what I did was I have defined things in a more readable way. So I have like, okay, get the first summation of these numbers at least 500. So if I want to make it for the first 1,000, I can run this. I hope this is the correct answer. Let's always double check. Summation of first 1,000 natural numbers. Yeah, so I think my algorithm works. I have tried this in few numbers. Let's try first 10,000 and run it. I think the number is also correct. Yeah, the number is getting way bigger. So I can try even much more bigger numbers. Okay, and try to run it, and the values seems to be working. Okay, right now run it once again. It is giving me numbers. Let me try integer max value. So that is I'm taking the numbers, but now I am chunked it out by 100 by 100 and run it. Yeah, still you guys can see it's not super fast. It is trying to calculate the numbers in a way, but the chunk size is 100. So it is first trying to calculate the first numbers, first few hundred, and since the value is really huge, it's going to take a lot of time to chunk it by 100 and 100. So it is taking this amount of number. Let me check. Yeah, so you guys can see even with chunked values, what happens is it's not able to calculate the integer max value. So what I can do is I can try to increase the chunk size rather than 100, let's say 10,000. Okay, and I'm trying to get the summation in here, integer, let's say s in here, and I have s in here. Okay, and I can print out system.out.s. So you guys can see what's going on in here, what's kind of numbers are it's generating. So you guys can see it's taking a bit of time. Yeah, so it is calculating numbers at least by 10,000 chunks. Okay, even with that, you guys can see that it is taking way more time to calculate that amount of numbers. Okay, so what I'm going to do is I'm going to increase the chunk size as much as possible. Smaller chunks, of course, take a lot of time to process, but even with a large chunk size, the integer calculation takes a little bit of time. You guys can see I'm not sure whether you guys can see my CPU stat, but it is going crazy. So larger chunk size, still I'm having trouble. Let me increase for the maximum chunk size that I can go. Yeah. So you guys can see it is going in patterns, but it's not fast enough so I can calculate the whole number. Sometimes it shows 0. I'm not sure why. So it's even the largest chunk size, it's not gonna help, right? It's gonna take us a lot amount of time to calculate the numbers that we need. So even I increase the chunk size, now you guys can see it's still, sometimes it's giving 0, not sure why. Need to check on that, why it is giving 0. Let me check. System out, I plus this one. Okay, let me run this. Maybe the range that I am taking. Need to add another system outline. Can't see the sure. Let's see. It's going on minus numbers. Why is that? I think the numbers are too huge in order to calculate. Might be that. Or might be another reason. Yeah, let's keep something really small, otherwise my CPU is gonna burst. So I'm gonna go with something like 100, 10,000, 10,000, 100, 1 million, that's kind of thing. So we don't have to burst my CPU. Okay, so you guys can see if we have, let me clear it out, run it once again, and there you go. So if we have like a little amount of numbers, then we can get the summation as we go on, like 20,000, 20,001 to 30,000, 30,001 to 40,000. So it's gonna take a little bit of time, but the calculations will return us with some of the values. Let me check, the integers are returned. Positive values only. Yeah, one thing you asked, so it can't be both negative values and positive values instead of showing the positive values only. Yeah, let me check on that. I need to refresh on that as well. Java in integer sum returns name values. Think it is exceeding the values. Big int might be a good option. Okay, let me check something like big int, big integer, new big integer. Starting from 0, sum dot add new big integer, which is s. Just this constants big integer big guy and I'm gonna print big guy. Okay, there you go. Error seems to be with the number points. Okay, still I get minus values. That's weird. Yeah, let's keep something very small. Otherwise, I have to explain a lot of things. I need to check upon why these things are happening. So I'll keep the minimum integer sum equals 0. I need to sum it up by yes. Let's keep it simple, otherwise it will take some time. But I need to refresh on my memory as well. So you guys can see it's taking a little bit of time in here to calculate even a big number. So if I put chunk size of 10, it's fairly much more faster for a number that that is manageable by one of these computers. But there's a point where we will be stuck on. So that is no longer be able to run by in serial manner like what we have done now. So my next attempt is, so you guys can see that these actions, the calculation that I am doing, the calculation part that I am doing in here is done in this code section. Okay. So what happens is when I'm creating this, when I'm invoking this function is running on this for loop. So this for loop call this function one at a time until the for loop is done with all the numbers we have. Okay, so it is calling and calling and calling one after another. Okay, so we can actually in here we can actually do something to simulate. Okay, so since this is running way more faster, my computer is like not that good, but to do something a little crazy like this, it is taking very less amount of time. Okay, so what I will do is I will check on one thing in this scenario. What is the current thread? What is the thread this calculation is happening? So you can think a thread as a mini process of our application. So when I am running this application, the whole application, it's gonna be running on what we call the main thread. Okay, so this execution flow happens like this. Some chunk, these variable allocations happen. The for loop start to loop in one by one, the looping conditions, it's getting executed. And at the end, the system end gonna call. So everything that happens in this calculations happens in what we call a main thread, the main um, execution point. Okay, so what we need to do next on this is rather than running these for loop in one single thread, what we'll do is we will take we will use something called threading. That means we will use this section, the running calculation part, into a separate thread. That means separate process, rather than hogging or rather than waiting the main thread to execute one by one. We will create multiple threads based on those multiple threads, we will execute the information, or we will execute the summation calculation in different sets. Okay, first I would show something you guys, the thread ID. Okay, so that is in what we call thread and current thread. So thread is one of the Java's native inbuilt classes, and it has this current thread, and we can get the ID of that. Okay, so every thread, thread ID, I think it's a number. That's a long. Okay, so I can print out this out the TID, or it's short for thread ID, and I will show the ID section here. So whenever I am calling this sum function, right before it is do anything, it is gonna show me the thread ID. Okay, it's gonna show me the thread ID of it. Okay, let me execute and see. So as you can see, there are a lot of executions going on. I will make the chunk size little bit larger, so we will have less number of executions. Yeah, so every time that I am executing this get sum function, the current thread that is running is in thread ID number 1. So every calculation that I am doing, get sum function get executed in what we call a single thread. Why? How can we be sure? So each and every time that I am calling this get sum, I am printing the thread ID, and all the time it is returning the same thread ID. Okay, that means every execution that happens in this for loop is happening within a one single thread. Okay, there is no multitasking going on. There is nothing going on in terms of execution in another thread. So we have one single thread. That thread is responsible for executing all the tasks that we have. Okay, so another thing that we can do in here is something what we call to simulate our execution, or to make our execution. Let's assume that this is taking a little bit of time to calculate the summation of start and end. Let's assume that it is taking a few seconds to calculate. Okay, so right now my machine is good in calculating or executing summation of these small numbers, but let's assume that we would take a little bit of more time to execute this section. Okay, so we can simulate that. We can block the current thread like this: thread dot sleep. Okay, sleep in the sense what I'm artificially creating a thread blockage. That means I am creating I have this thread number 1, and I am artificially sleeping the thread. That means I am pausing the execution of this thread up into 1 second. Okay, so rather than executing without a stop, I am deliberately saying, hey, stop this execution for 2 seconds. This is in milliseconds, so 2000 means 2 milliseconds. Okay, I can have to like 1 if you like, and this is gonna give us an exception. By why? Because this is like interruption exception. We can interrupt thread execution anytime. That means if you think thread is taking too much time, we can interrupt it and stop the execution. So we need to try catch. So any exception happens, we need to try catch it. So now if I run this action, see the output and how it goes. Okay, if I run it again, now you can see it is not executing in in faster, like what we did earlier on. Is sleeping for a 1 second and resume execution. Okay, so the execution that we are currently doing is in one single thread, but the thread is sleeping at 100 milliseconds. Okay, so whenever I am executing this, the thread becomes sleep for 1,000 milliseconds. That means after 1 second, the continuation of this thread execution happens. Okay, so by this simulation, it is not something that we need to do. We just pause the execution for a little while so we can see that okay, we are running in the same thread, and um, we have deliberately introduced a delay in our execution to simulate. Okay, it's not something that we should be doing or something like that, to simulate that this is going on in a single thread but with a pause. Okay, now what I'm going to do is, rather than depending on one single thread, I have one single thread running on here. Rather than depending on one single thread, what I will do is I would create multiple threads. Okay, I would create multiple threads and within those multiple threads, I will be executing this summation function. Okay, so rather than me executing all these function in one single thread, what I would do is I would execute these things in multiple threads. Okay, so let me boil down, or let me like uh, make it 10 times faster by sleeping less. And if I terminate this and you guys run it again, now you guys can see it is taking a little bit of pause in order to get the execution done. 100 millisecond pause. Okay, still in the same thread ID. Now what I will do is, rather than depending on one single thread, I will create multiple threads. So in order to create multiple threads, what we can do is, in Java, we have something called uh, thread interface. Okay, so in order to create a new thread, we have thread interface, or otherwise we have a nice way of getting this done by implementing something called a runnable interface. Okay, we will see how we can create a new thread and execute that information and get back the result. Okay, so the runnables will help us need to get this up and running in different threads. Let's see how we can get that one as well. So in order to do this, the application, to get the application in multiple threads, we will use the thread interface, the creating threads, new runnable interface, and so on. So we will check one by one. The first thing that we will do is create a new thread using the thread class that we have seen in here, thread. And what I can do is, sorry, new thread. Okay, then I need to have a runnable target. Okay, so we call have a runnable target. Okay, I can create a new runnable in here, but the best thing about creating a runnable target is we can have it to make the object much more cleaner. We will implement the runnable in a different thread. Okay, so we will implement the runnable method in a different thread, so it will be much more cleaner in terms of reading and doing all these um, thread calculations. Okay, so let's see how we can create a new thread by using leveraging Runnable. Oops, sorry. So we create a class that have the Runnable option. I'll say, I think I am in, since I am in the main class, I can't. Yeah, I need to create a runnable class since it is Java, always forgot. I need to create another class. I will create some class, okay, to make it, it's not the best class name, but I will create a some class. And I need to implement runnable interface, okay. So the implementation of runnable interface would give me something that since I am implementing an interface, I need to override the implementation unimplemented methods. So in here, the runnable interface have something called run method. Okay, so if I want to execute something in here, I need to execute this run method. Okay, so by leveraging this run method, I can execute whatever I want. All right, so uh, what I need to do is I need to execute this. I need to run whatever I want in here and get the things running and make the application runnable. Okay, so how I am gonna create this uh, how I'm gonna create this runnable interface to host my summation and do everything in here. So one thing to remember, so the run method is void. That means after running this code, there is like um, uh, there is no return of this execution. Okay, it will run and that's it. There won't be anything that we can do in terms of like uh, uh, executing this one and returning something like that. Okay, the runnable interface, it's just gonna create uh, summation. It's just gonna run and do the execution. Okay, let's see this in action so you will get more information. Give me a second. Da-da-da. Uh, Okay, so what I'm gonna do is, since this is some class that I'm working with, I am gonna get some private variables instantiated. So what I'm gonna do is I'm gonna move this function, at least not this section, but starting and returning sum into a different section, and I will be creating threads based on that. So start, end, and sum, those are like the three variables that I'm working with. So I'm going to create those variables in here. So I have a start and end, and I have integer called sum. Okay. So when I am creating this sum class, okay, so earlier on, what we have done is we have just passed the variables in. Right now, in runnable interface, you guys can see it is what we call a void interface. So we can only run this section and get the summation back. So what I'm gonna do is I am gonna do the start and end calculations that we do in here, and I will define a public long, or it's going to be an int, and I will say get sum method, and just return the sum variable that we have defined in here. Okay, so what I have done is I have this run method. So if I call the run method, what it's going to do is it's going to start and run till the end, and it will get the summation of that. And if I want to get the summation back, I need to call this get sum method. Okay. So the next thing that I am going to do is I am going to call the executions of my threads. Okay. I need to create the thread execution. Okay. I need to call this sum class and start executing. Okay. So how I am going to do that? Probably I would not need this anymore, hopefully. So what I'm going to do is, since I have implemented the sum class, by using the runnable interface, I can run this class, the sum class, in a thread. Okay. As long as any class in this scenario, the class called sum class, is implementing the runnable method, I can execute this sum class in a thread. So how I'm going to do that? So let me just comment out this one for some second, and I will say new sum class, and you guys can see I don't have like passing options to this one. So I'm going to create a constructor, sorry, some class, and it will take start as it will take integer, what we call start, and integer what we have like end, and I will assign these to this dot end equal end, this dot start equal start. Okay, so while we are creating the sum class, it's gonna ask for two variables, that is the start and the end, and it will execute the run method, and we can call the get sum method after all. So the sum class is expecting a number, so I am gonna start with 1 to, let's say, 100, something that we know. Okay, so I have created a thread instantiation. Okay, I have created a new thread, but I will call this const, let's say, sum1. Okay, okay, it's gonna be a thread type. So okay, so sorry, it's some class, and it is I have created something called sum class. Then the thread execution does not happen unless we invoke it. Okay, unless we uh, invoke the thread execution to happen, we will have no execution point. So if I just call this, and I can say sum one dot get sum, this method, it should return the number, right? So it is the summation that we should get. Let's see what happens, whether it's gonna work or not. So I will instantiate an int called I'm gonna call sum. I will call this an sum thread. Okay, otherwise I'm getting out of someone, and yes, system someone. So right now what I'm doing is I'm creating an instance of the sum class, which I will pass 1 and 100. So basically, if the summation happen, it should return me the summation of 1 to 100, right? That is the expectation. And thread sum, the class that I have created, I have called it thread sum thread. And if I call the sum method, it should return the sum that I am expecting. Let's see how this one goes. So there is two sums printing out. I'll remove this. So the summation of in here is 0. That means the execution, the summation did not happen. The initial value at the summation is by default it is 0, since it's a primitive value. And if I call the get sum method, the sum is also 0. So in order to execute this section, in order to run this in a new thread, what I need to do is I need to call this run method. Okay. So normally you would say, okay, you can just call the run method and see whether it is working. But in here, we need to create a new thread. Okay, so we need to create a new software thread and execute that one. So what I need to do is I need to invoke that by simply calling the thread start method. Okay, so every thread have this method called start. Then what it will do is it will start this thread. Sorry, thread new start. Give me a second. Oh, sorry, new thread, some thread, then start. Sorry, start. Okay, so what will happen is now this is a runnable interface. The runnable interface should be feeded to a thread interface, thread class. The thread class will take the runnable interface, and once we call the start method, what will happen? The thread will run and summation would be get done. Let's see whether this is also happening. Let's hit run. Still we got 0. Okay, but something that we can do in this run section, I would say system out, and I would say sum in run method would be the sum that we see. So if the run method executed, the this statement would show up and it will show the summation at the end of this run method. Okay, let's try to execute that and see. Now there's something interesting happening. Yeah. So let me run it again. So see what's happening in here. This 0 represent in here. Let me give some context to it. Sum of all or something like that to indicate what's going on. So you guys can see I have started this thread. I have called the get sum method and I am printing it out. Correct? But when I execute this one, sum of all is executed first, then sum in run is executed. what is going on here? If we take into a consideration, it should in algorithmic way, first we create a sum class, that is fine, and we create a new thread and call the start method. By calling the start method, what will happen is the sum class is having this runnable method which will start executing. Okay, this execution start immediately. Okay, and even though that execution happens, we get the sum in here. So execution started, summation calculated, this is shown, and this we call the get sum method, and we are trying to display this. So if we take the execution order, first we should see this message, then after that we should see this message. But what happens is the other way around. First we see this message, the sum of all, then after a little bit while we see the execution result. Okay, so what's going on here? Another thing that I would show here is if I go to sum class and I would print out system out dot in here TID. I would predefine or I would prefix some class to identify the class that I'm in, and I would say thread get thread dot current thread get ID. So I am getting the current ID in from some class, and I am also getting the thread class introduction to thread. So I am printing out my thread ID in two different places. One in the sum class, I am putting out the thread number or thread ID. And also in the main class, intro to the thread, I am also putting the thread ID. So let's see what's happening in here. Okay, so sum of all is 0. That is fine. Introduction to thread is 1. Okay, that is the thread ID. Let me put the ID in here so we are not confusing. And in here as well, TID, thread ID to indicate. If I go here and execute once again, sum of all is 0. Introduction to thread ID is 1. Sum class TID is 14, and sum in run is this one. So you guys can see now the sum class thread ID has for some reason changed. It is no longer running on the main thread, which is having the ID 1, but it is running on a thread which is called 14. Okay, so execution happens, but it's not in the main thread, but in a different thread. Okay, so the delay between the sum of all is 0. This is shown to us. Why? Because if we start a new thread, the execution of the rest of the application, so execution of these steps, does not wait until the execution in the run method stops. Okay, so that means whenever we are creating a new thread, the content, the execution of what's happened in this sum class, and as I mentioned, it's gonna execute the run method that we have in here. It's start to execute, but in another thread. Okay, in another thread, it's in another sub program. So the rest of this execution, the execution that happens in here, continue without irrespective of this task, this thread is completed or not. Okay, it doesn't wait until this thread is completed. It's start executing. That's why even though we started the execution, these lines are shown to us. It is going ahead with execution, but after this thread is done with this execution, that means after the some class run method is executed and the result is shown to us, then we have the result back. The sum is in here. Okay, so the execution would be happening. Okay, execution will be happening, but the execution right after it happens, it is shown only after the thread is completed. Okay, let me do another thing. So I have one thread in here. Now I am gonna create another thread. Okay, let's say T2, this one, and I'll call this one T1 for sure, short. Oops, T1, this one is T2. So I'm going to say start the new T2. Right now, it doesn't matter if you go like 101, 200, but just to make it more readable at the end. What I'm going to do is I am going to call thread 2 start. Okay, so this is thread 1, this is thread 2. Okay, let's see that in execution. So you guys can see that sum of all is 550. Okay, we are getting 550. So introduction, intro thread ID is 1 in this scenario. And you guys can see sum of class ID in TID is 14, and some class TID is 15, and some in run, that is 1050 and 150 and 150. So you guys can see executions happens. Some of the values that we are getting, it is shown in here as well. The sum 1 is actually we can get that value, and sum 2 we might get that value if we call this one, but I'm not, I'm just gonna temporarily avoid this. So what I need to show this in here, some class thread ID is 14, some ran in this order, introduction to thread is thread ID 1, okay, and some class thread ID 15, some class thread ID 15. So right now there is something that you guys can see, the introduction to thread ID, it happened a little bit later on. Okay, first execution happened, that is the thread ID 14, and it gave the sum. Then the introduction to ID happens, that is completed. Then the thread ID 15 and the value was executed. So now you guys can see there is something going on here. The order, execution order, is not what we are expecting. We are expecting some thread 1 to be completed, thread 2 to be completed, and introduction, the thread ID of this one should be showing up, right? But right now what happens is, first this one get executed before we start in the second one, before we ending the second one, this got executed, and thirdly this got executed. That's what's happened in here. So if I run this again, okay, so it's happening like kind of the same way, but you guys can see the output did change. Look at this. So the sum class thread ID and sum class run 550. Now thread ID started showing again the thread ID, then the summation. Now what happens is the execution that we are trying to see, it is giving output in, sorry, it's giving the output, but not in the order we assume. So let me create another thread like this, say for 201 and 3000. Let me execute. Okay, I can't use T2, I have to use T3 and start the new thread. So right now, I'm also creating another thread, okay? Another thread in here. Let me clear this out, run it once more time. You see, guys, now I got the thread introduction to thread, then the summation happens, then the calculations happens. Okay, so yeah, the expected output of our execution, thread-based execution, are getting what you call in a way that they are not giving in the order that we have asked. Okay, sometimes it's 15, 14, 16, sometimes it change. So the thread execution process might be not the execution order that we provide. So that is something we need to remember carefully when we are dealing with thread-based applications, that the order of these application, it is not the way that we are going with. The execution might be different. So what I'm going to do right now, rather than rather than uh, executing this one really fast, I'm going to use the old trick that we had earlier on. So I'm going to remove thread ID for now, and I'm going to say thread dot sleep, and I will sleep, say 100 milliseconds. Okay, I need to wrap this in a try catch so I don't have any exceptions. So right now, what I'm doing is, while executing, I am giving a little bit of sleep time for this thread. That means the thread is sleeping for 1 second. Okay, let me run this once again. Now you guys can see that the sum of all of these threads executed, and I got the results back. But if you guys can remember, if I had this summation method in here, okay, summation method here, and if I thread sleep for this amount of time and get some method in here. So what I'm going to do is I'm going to remove all these parts. So I have, let me put the millisecond 100 in here. I have 100 milliseconds. Let me make it 100 milliseconds in the runnable as well. So this function, I will copy this function to associate with the thread. So I have this in here. So I have T1. So the start will be I, and jump -1, that is end. Okay, so I have two methods now. I have two methods. Let me remove this code to make it clear. So I have two methods. One summation is done on thread base one. The other one is just an old execution that is happening by loop. Okay, so if you are doing thread-based execution, if you are creating a new thread and start, let's see how it goes, and let's see how it goes when we are executing the same number in the order of the summation execution. So what I'm going to do is I'm gonna execute this one first, see what's going on. Let's run this. So the TID is still printing out. Okay, now it stopped. But in summation function, you guys can see all those things ran. And of course, this started a little bit later. But everything that I have started is executed very fast. After a little while, everything got started to execute in thread 1. So I'm gonna do one thing. Summation class, I think don't need the sum, but I need the sum thread. Okay, let me show once again. I hit run. So all these threads, now they are done with the execution. Okay, that's why it is showing the thread ID. But once we are running in the main thread, it is taking a lot more time to execute, and it is one by one it is executing. But in here you guys can see it is creating multiple threads, creating a lot of threads, and start execute. But remember, the thread execution process, it is not happening in a way that we would expect, like one after another is happening. No, it's not like. So the thread ID creations happens in a sequential manner, but thread execution or end happens in a different way. So first thread that got execution was 15. The second one is 17, 19, 22, 18, and so on and so forth. Okay, there was like 110. So if I run the same execution, remember these first three numbers, first four numbers, 15, 17, 18, 19, and 22. These are the thread IDs that was being executed. Okay, these are the thread IDs that been executed, and this is the order. But if I run it again, and let it run. Yeah, it's gonna take time. So I'm not gonna confuse and go here. So now see the execution order. First one got executed was 14, then 16, 18, 20, 17. So the execution on threads, when we are executing these things in a different section, what happens is the thread ID, thread execution happens in not the order that we submit, but in a random order. The reason behind this random execution is the CPU timing that it gets. Okay, so for some reason, the CPU time that we got for the thread ID 14 was something it got earlier on, but the system has 16 next, 18 after that, but look at where 15 is. Okay, right after 14 it should create 15, but the execution time, the context switching happens in CPU, and the CPU time allocation that happened for 15 happened all the way after these execution were done. Okay, so in parallel execution, in thread execution in this scenario, we can't guarantee the sequence or the order of execution. The sequential execution is not guaranteed. Okay, you can't expect, it won't execute these things one after another. So if you are doing something like that, it is something we can consider like what do you call serial execution, or we can even, someone can think this is dependable execution. Okay, so by creating many more threads, and even the thread execution function is like pretty much the same, right? Pretty much the same. So we are doing a thread sleep in here, and we do the runnable instance, also the thread sleep here. Okay, So it might be a little different based on it was on top, but this function execution like really simple. But even if we put it in on top to match the perfectly as it is in here, okay, the execution of these things is what we call is little, not little, but different. Why? Even though we are executing this in a new thread, we are giving them a small time to pause execution. In here, we are also giving pause execution. But since we are running in a different thread, we are not relying on the main thread like what we see in the for loop, but we are executing those things in multiple threads. The execution happens pretty quickly. Okay, so this is how we can, you guys can see that these executions gonna happen. Even you might think, okay, the threads got a heads up and it is starting earlier on. Let me do the opposite. So let me give the normal for loop start execution first, then the thread execution later. So what will happen in this scenario? Tell me. So in this scenario, you would see the execution for this thread section will have to wait until this is done. Let's see why. You see, now this is sequentially executing. None of these getting executed in parallel. So it is taking a lot of time to execute. And right after that happens, right after this happens, the execution of these got started and executed at one go. Okay, so if you are blocking this, if you are trying to have this in, yeah, if you are trying to execute this one in, even though this is in a thread environment, the summation happen in a thread environment. Until this is done, it is not gonna execute. So what I will do is something crazy. I will put the new thread and I will say new runnable, and I have to override the run method, and I'll say dot start. So summation I need to put it in the local thread, otherwise it will not work. So what I'm going to do is the values, the non-thread version, I will start this one is in a new thread and threaded calculation in another thread. So for loop happening every time a new summation comes in, let's create a new thread. But in this scenario, what I'm going to do is put these two threads in two different threads. That means the first one would start the summation in a serial way. The second one would start in a thread banner. So what will happen is both of first one, it will start in a new thread and it will run. And the next one will start in another thread and it will start to run. Let's see how it runs again. Now you guys can see, even though all these two threads are started right after another, okay, this one is still not using any threaded environments. All the calculation is done in a normal way like this, but everything in some class is on a different thread, so those execution happen really fast. Okay, so even though these two started at the same time, execution of this one started immediately and done with that. Okay, so the TED ID 14, that is this thread started, and all the time, or at the same time, all the threads that we having in this section, they got also started at and ended even before the next one of that synchronous thread got even started. So remember, thread execution will drastically improve your uh, execution time, but the problem arise when the execution order is not in a sequential manner. Okay, that is something that we need to know, and that's something we need to address even when we are creating multiple oh, multi-threaded applications. Okay, but remember, this is software based and CPU based multi-processing. Okay, so it has its trade-off. Okay, we haven't talked about things that we can do in GPU based multi-threading. That is another uh, code of things that we need to think. The execution happens in a GPU is somewhat little bit different. Okay, we'll see those things in action. Right now, up until this section, I hope you guys understood how to create a thread and start execution using runnable interface, and how you guys can create multiple threads even like this, and chunkization that I'm saying. So my next assignment kind of thing, a coding assignment that for you guys is to create a simple Java program like this. Of course, you can modify this one, modify and get some clarification, but I don't expect that much of performance all over serial and serial computation and parallel computation due to the number of data. As you guys can remember, the number of data matters when it is coming to parallel and serialization. We will discuss that in a later on, but the assignment should be like using threads, calculate the summation from let's say 1 to 10 million. Okay, and use the same algorithm, or uh, use some sort of non threaded version to calculate the same number and see which one is faster. Okay, execution time, of course you guys can print out the execution time and see which ones performs much better. So the first one is to print out the numbers, or not print out, take the summation of 1 to 1 million using threads, and without using threads, see the difference, see how it can goes. Okay, probably since it is less data points, okay, at least I mentioned like 1 to 1 million, that's very little amount of data compared what we are going to look into. So the 1 to 1 million data is like nothing. I don't expect the parallel algorithm, the thing that we do with threads, will win. Okay, the serialization should win in this manner because of the small data, but let's see how it goes. Uh, Summation 1 to 10 million using threads and without using threads. Okay, anyone have any questions on the assignment? Okay, anyone have any questions up until this? Any things? So if you are new to threads, create a new thread, execute, enable. So I'm using this inline inline classes. Okay, or you can use something like separate classes for execution. The better and more cleaner way is to use a separate class for extending, but this is also can be done, but the readability of the code is not that good. Okay, anything that I need to explain in these sections? Okay, let me stop recording.